So we talked about random variables and we talked about expected returns, right? And I think if you go back and read up this thing, it should be pretty clear as to what I'm talking about. Uh, I know it could be a mouthful sometimes in terms of understanding a little bit of this, but I think the notes should be pretty self-explanatory if you spend some time sort of reading and looking up all these concepts, right? These are important to understand so that you sort of know when you're dealing with data set as to how to sort of go about analyzing and looking at some of the different features, right? Uh, so let's go back to where we stopped last time. Okay, uh, we talked about expected value, expected returns. Okay, so let's go back to that pizza parlor example, right, where we estimated that if we were to buy that franchise based on the data, right, based on past data, you were expecting to make $148,000 in profits, right? But you know that is highly unlikely, right? That you'll make that exact amount, right? So there will be some volatility around that number, and that's measured by something called standard deviation. Okay, and I'm sure you would have come across this word somewhere, right? In your daily life, and these are pretty important concepts in the sense that we're going to be using that over and over again, not only here in this course, but also in your real life, right? So, standard deviation is a measure of spread, right? Uh, but in order to get to that, we need to first calculate the expected variance, commonly just referred to as variance, right? It's basically the average of the square differences from the mean. Okay, so now I know it's a mouthful, right? But let's try to sort of understand as to what this thing is, and it should be pretty clear. Okay, so uh, let's look at this middle term, right? So this is the outcome of an experiment. Let's say it is. Uh, uh, let's take a six-sided die, right? You toss a die, right? You have 1, 2, 3, 4, 5, 6 possible outcomes, right? Uh, and you add them all up and you get that mean, which is the expected value. So here is the mean of all those outcomes, and each of those outcomes, it could be 1 minus the mean, 2 minus the mean, 3 minus the mean. So there is some spread between each of those outcomes with respect to the mean, right? And then you square them, okay? And we'll get to as to why you have to square them. But you square them and then you take the mean of that, okay? So you're basically taking the mean of the distance of each outcome from its mean, right? And that's how you can sort of calculate as to what the spread is. Okay, so let's think about it again. Okay, let me see whether I can sort of explain it using some kind of a drawing tool. Okay, okay, so I'm going to do this Khan Academy type. Let's see whether I can do it. So you have this mean. Okay, let's say you have this mean, and this mean is basically the average of all possible outcomes. Let's say you have a data set, right? You have a data set, okay, and you have a column of data, say measuring height of someone, right? And you calculate the average of that thing, right? So you have this mean, and then you have some data from that mean, which is going to be here, some here, some here, okay, some here, and so and so. So you're going to have all these different data points, right, around this mean, right? How far away is this from this? Okay, that's x minus ex. Okay, how far away is this from this? Okay, which is x. So this is x1 minus ex, this is x2 minus ex, and so on, right? So you have all these different measures, right? So you calculate all of them, okay, you calculate all of them, okay, and because it's an expected, right, because it's an expected value of the difference of each outcome from its mean, you have to add them up, right, because expected means you have to add them up and you multiply it by the probability of each occurrence, right. So that's why expected means you have to sort of sum, right, because you want to see expected of the difference of each number from its mean, right. So I'm not sure how clear it is, but if you think about it, it's pretty evident as to what I'm trying to say here, right. So another way to sort of write this is each of those outcomes from its mean, square them, and the probability, multiplying that with the probability of each occurrence, right. So for example, if you have 10 data points in series, each data point in that column is in that series occurs 1/10 of the time, right, in that sample, right. If you have 20, it occurs 1/20th of the time, right. So that's your probability of occurrence, okay. And this ex is nothing, expected value of x is nothing but the mean, and that's what we are simplifying, right. I don't want to get into the population and versus sample mean and all those discussion, but let's leave it for another lecture, okay. So we calculate the variance that way, okay, and since pi, as I said, probability of occurrence of any one event in that column, okay, is just 1 over n, right, because you have 10 data points, it's going to be 1 over 10. We are going to simplify that thing further, okay. If we have 10 instances, it's going to be n is going to be replaced by 10, because this pi is going to be 1 over 10. So if you have 10, it's 1 over 10. If it's 100, 1 over 100, and so on. So each occurrence would be 1 over n. And the standard deviation is nothing but the square root of variance, okay. So hope that it was clear. So we talked about this thing called it's mathematically defined as the average of the square differences, okay, from the mean, okay. What's the deal with summing the square differences for variance and then taking the square root of that number to arrive at standard deviation? Because ultimately you want to get to this number, standard deviation, as to what is the standard deviation around your mean, okay. So imagine we had large number of data points, some to the left, okay, as we were showing here, some to the left of this mean, some to the right of this mean, right. So since you are doing x minus the mean, right, so some differences from that mean would be negative, okay, and some would be positive, right. So if you were to sum all of them up to eventually get to a standard deviation, if you didn't actually square them, right, and square is just basically a mathematical trick to sort of make everything positive, okay, if we didn't square them, we would get a big fat 0, right, because think about it, this is a negative number, this minus the mean is going to be a negative number, this minus the mean is going to be a positive number. You are summing them all up, so if you sum those two up, you're going to get 0, right. So that's the logic behind squaring and then taking the square root, okay. So hope that is clear on that front, okay, as to why that squaring business, okay. So let's go back to that pizza parlor example again, okay. So you're going to do exactly what we decided to do, and you're going to calculate the standard deviation, okay. So the standard deviation happens to be, when you do the math, okay, it happens to be 74,269. So basically the way to sort of state that data point is that if you were to buy that pizza parlor, you will be expecting to make $148,000 plus minus $74,000 most of the time, okay. Of course, there is another caveat, okay, and we are going to get into that as to how do you take these two numbers and make predictions, okay. How do we take these two parameters out of this sample data and start making predictions about the future, okay. and that's where the game is, right? Because that's what we are trying to sort of do with this uh, with this course. Let's continue, okay, a little bit more. Okay. Uh, so let's go back to that asset class returns data, right? And as you can see, we can take the mean of that data by asset class. Okay, so large US equity returned 11.6%, small 12.7%, okay, 12.69%, okay. REITs did 13, so not that much difference. See, REITs and small cap are pretty close in terms of return, but REITs did twice the amount of money. You made 2x the amount of, like $1,000 turned into $250,000, whereas in small use equity it was only $120,000 or $125,000, right? So there's a big gap, right? What explains that gap? What explains that gap is the standard deviation differences, right? Small cap equity were actually more volatile than REITs, okay? See, cash is the least volatile asset, followed by bonds, followed by the crazy commodities, okay? So commodities not only give you less in terms of average returns, okay, each year, but it was far more volatile, and that explains the significant underperformance of that asset class over time, right? Uh, and then some other numbers. So this sort of gives you that, okay, so now we know as to what we are trying to do, right? We are trying to sort of design a portfolio which so we just don't want the highest rate of return. Okay, so this is, we are applying some of the concepts of mean, the random variables, and standard deviation to money, right? Basically, okay. So we just don't want the highest rate of return. We want the highest rate of return with the least amount of standard deviation. Okay. So when we hear the word risk in the financial markets, right? When we hear the risk of say losing money in the financial markets, a lot of the times, so there are two flavors of that risk. One is total capital loss, right? Where you buy a single company, or let's say you invest in a small company down the road, right? And you buy a, say, pizza franchise, okay? And you invest some money in it, and that pizza franchise closes down, you lose everything, right? So that's risk of loss, okay. When the financial guys talk about risk, they're talking about standard deviation most of the time, okay. So risk or volatility adjusted returns is what counts. Volatility is another term for standard deviation, right? So as I said before, a 50% drop in value of your portfolio does not take a 50% return to come back, right? So $100 becomes $50. If you add 50% return, you're going to get to $75, right? You're not going to get back to $100. You need 100% return to get back to $100, right? So minimizing the drop in the first place means that it might be a lot less harder to recover the money you basically your portfolio actually went down by, right? And first of all, you never lose money until you don't sell, and you don't design a portfolio which you are going to sell, right? So there is a little bit of behavioral components to that in terms of how you react to different market events and all those things, right? So there is a little bit of that thing. And minimizing standard deviation means, okay, minimizing variance, or better yet, optimizing for variance for a given level of risk, right? And hence we are going to get into mean variance optimization, right? So what we're trying to do is we're trying to sort of make this a little bit dry, at least to me, right? It's a little bit of a dull topic to sort of talk about, but it's needed. And my promise is to not to sort of dive too much into the math part of all these things, right? We want to sort of cover enough so that we have the necessary tools to work with data, right? So we're going to talk about mean variance optimization. So just take this as some way to sort of look at your portfolio, as to how you build portfolio and how do you understand some of these concepts, so that you can apply to other problems in your life and in your career. Okay.